Here, electrical metallic tubing. This is 3/4 inch in size. And notice it's a thin wall conduit. So the conduit's very, very thin. And in comparison to the threaded rigid conduit, which is over here, notice that it is actually very thick. It's known as a thick wall conduit. Now, EMT conduit cannot be threaded. You have to use connectors. Whereas with rigid conduit, yes, you're using connectors and couplings as well, but it's all threaded. As you can see, we've also got some other examples of 1 inch rigid right here. We've got these little protectors to protect the threads from being damaged. And I started the trade working on gas stations and doing lots of threading of rigid conduit. So that is about it for this room, and we're gonna go for a walk next door to the motor control lab, and I'll show you some other things. So follow me, class. After you. All right, we are now in the second year motor control lab. Actually, I'm not sure what year it is, but the motor control lab. If you happen to notice right above here, that is called a cable tray. Cable trays come in practically any size you want in terms of width, depth, whether it's ventilated, non-ventilated. There's some examples of it just right up here about different types of ventilation. However, be very careful what type of cable you install. For example, if it's exposed to the weather, you have to make sure that the cable's approved for the purpose or the application. So that is cable tray, which is part of Raceways. Next, we have this device right here where you make splices, and that is called, any ideas? A splitter. A splitter. So we're actually splitting the power in different directions. So we'll actually come in with a large conductor, perhaps rated for 100 amps, and then you end up tapping off the splitter to certain overcurrent or overload protections, for example with motors. So this is what a splitter is. Down below here, I'll just move this ladder for a second. We have what's called a wireway, much like used on the other side. We can bring multiple wires down into this wireway, and we could have, for example, any number of conduits going underground to feed other locations. But this is what a wireway looks like. We've also got this device right here. Not too many. I don't know if this is used too extensively anymore, but there is a lot of this downtown. I've seen a lot of it in downtown Vancouver. This is called the plug-in busway. We used a lot of it back in the 80s and early 90s in office high-rises. So you didn't actually bring a feeder up to each individual floor. You actually brought a busway with common voltage and current, and you actually plugged in these taps on each floor. And this is what we use to feed a lot of the office towers downtown. Now, if you want to come a little closer and be safe, go up on the ladder if you like. You can actually see where these buses will actually bolt in to the busway, and you can actually tap off to feed, for example, floor number 10, floor number 15, or you can easily put in a second distribution panel on a particular floor. So there's a lot here in the lab that we can show you. Oh, by the way, class, follow me down around the corner. There's some cable tray down there that I'd like to show you, and what's really important is the cable spacing between the cables, and it's used for derating. So follow me one last time. We'll go down the hallway. And one nice thing about here at BCIT, we don't hide anything. So if you want to see Raceways, it's here. If you want to see junction boxes and taps, it's right here. So we'll just go down. Ah, darn, that's on the next floor. Well, sorry about that. The cable tray is actually upstairs on the other floor, so sorry to waste your time on that.